All right, everybody, continuing with my videos where I get some questions and answer while explaining the reasons for the answer. This is the video 4. In this, so I have the first question here. What is the symbol for the element chromium? So you should keep a periodic table, and it should be your guide always. You can write down things that will help you around it, and you should know what information you can derive from the periodic table. So they're asking what is the symbol for chromium. So it is simple. So yeah, you look at the periodic table. If you have a periodic table that gives the symbol and the name and all the important the atomic mass, atomic number, then you can derive most of the information. So first question I have here is, what is the symbol for the element chromium? It's Cr. Then the next question asking, what is the symbol for lead? Lead is Pb. Lead is Pb. So most of these names come from Latin. So Pb means plumber. Plumber. That's why it is coming from that. Okay. That's why it's Pb. It means lead. And so that is that. It's chromium. There's another question. What is the name of the element with Sr? That is strontium. Strontium. So these questions are just direct questions from the periodic table. Next question is, what is the element K? Potassium. So you can just remember these things, but potassium K is it's in, and it's kalium. Kalium is ash. In ash you get potassium. When you burn trees, you hear this popping sound. That's potassium burning. So K, kalium. So it's, if we are using K symbol for the periodic table for potassium. So this is a classification, can you remember we check whether it's a pure or mixture. Those ones, if you follow those videos on those things, which I have covered. Which classification below would best describe chocolate chip ice cream? Chocolate chip ice cream. It is heterogeneous. So I read out the question and then I tell you the answer. So heterogeneous mixture is when you have one of the examples, chocolate chip ice cream, because it has a liquid, it has solid, it is not in one phase, PHAC phase. Okay. Yeah. Another question about what reaction? It's the physical or chemical reaction. When gold melts, what happens? It goes from solid to liquid. So that is a phase change. When there's a phase change, that is a physical reaction. Nothing happens to the chemical formula or chemical composition. Just a physical change. Okay. These ones. The state of matter in which particles are very close together is. So it's solid, right? Particles are very close. Solid. Not that close. In a liquid, then gas, it can move about free. So the particles are very closely packed or very close. Closely packed would be solid. Another question about what is the symbol for Mg, magnesium. OMG, it's Mg, magnesium. So what is the symbol Sn means? Okay, it is tin in English. That means stannous or stannic, depending on the oxidation state. But Sn comes from stannous. That means not tin. Sorry, tin. It's tin. Okay, so they're given a graph. My next question I have here, they're given a graph like that. And this cuts at 40. This is coming at 6 point. So let's start by 1, 2, 6. Okay. And then all these numbers. So, but what's the question? Okay, so they're asking what this graph represents. This graph represents. That's the question. What sort of a plot? The answer is y equals mx plus b plot. Y equals mx plus b. So b is the where it intercepts, where it cuts there. M is the slope. The slope. I can tell you this slope is negative slope. It's a negative slope because it's like that. But if the graph was like that, that's the positive slope. Okay. So how do you get the slope? You get you do these two crosses. This is mathematics, and you get this value divided by the other value. Okay. All right, they're asking the same thing in that they're asking the slope of the graph. So the slope of the graph slope. They're asking this thing, which is the slope of the graph. It is the answer would be 5, because if you select, so here you had to look at the graph. So they have these points here. So you select one of these points. Okay, so get this y2 minus y1 by x2 minus x1. You get that. So how do you get this? X2 and x1 is just 2 points, right? Y2 is these 2 points. Okay, so this is first and the second is lower. So it's a negative value you get at the top. That is why the slope is going to be negative. This is mathematics, everybody. It's not chemistry, but we are using these graphs. That's why they give the question. Let's see. That's okay. All right, then they're asking the same graph and ask what is the intercept? Intercept is B, where it cuts the y-axis. So intercept is going to be what? It's going to be 40. Intercept is going to be. When they ask intercept, you just look where it's cut. When it is a slope, you have to then get the 2 points in the y-axis and 2 points in x. So what you do is you put a cross here. I'm just going to again. So this is first y, and this is second y. So y2 minus y1 means lower minus higher one, you get a negative value, right? So that's why the negative slope. The other ones is x1. It's the same thing. Okay. All right. Because x is increasing, y is decreasing. That's why the slope like that. Okay. So, all right. Okay, this is about density. Question about density. Archimedes story about the density. Which one of the following insoluble substances, they're insoluble, that means they don't dissolve, would float in water, float to water. So the density of water, we can take it as 1. Density of water, if you take it as 1, whatever the value given that is less than 1 would be floating. So they have given a set like hexane 0.66. I'm not going to write the units, I'm just pointing to the important part. Diamond 3.52, bones 1.80, and ebony wood is 1.2. So all of them 0.66 is lower than 1. So whenever something, the density is lower, it floats. So if you put hexane liquid will be on top layer and water would be at the bottom layer. right? So this is immiscible solid because they are not soluble, they are not dissolving. So these are immiscible solid, immiscible liquids. So the answer is hexane. The reason is because its density is lower than 1. For the exam, if you get something else, and look at the numbers and see which one is lower than water, which is 1. So you must remember, is water, the density of water is 1. They haven't given. All right, this is a question about a density. Perhaps you have done these things for density. So you have a cylinder that has 25 water, and you have 22 grams of chromium metal. The mass is given now. They put this into it. So you say, so whatever the shape is, so you put it there. So when you put it, the water rises. It was 25 at the beginning, and it goes up to 28.1 milliliters. Okay, from 25 it goes to 25. So they're asking what is the density. The volume difference, 28.1 minus 25, you get some volume, right? That difference is the volume of this chromium metal. Okay, so 3.1 milliliters would be that. The mass is 22 grams. They are given that. So what is density? It's mass per unit volume. So mass is 22. You divide by 3.1, then you will get the answer as 7.1. If you're going centimeters or milliliters, depending on that. But answer is 7.2. So what you remember is, what is the formula for density? Mass divided by volume is density. Now, in this case, they just ask density, but sometimes they might ask the volume. They will give you the density, and they will give you the mass, but there's volume. So it's a matter of rewriting the formula, right? So if I d as density, mass divided by volume. If they're asking the mass, it is d times volume. If they're asking the volume, it is mass divided by density. So these are the three things you have to remember if you can't derive just by remembering one formula. You should be able to derive them if you mathematically, you know how these equations could be interchanged. If you have a difficulty in interchanging, if you don't understand how an equation could be interchanged, then you have to do that. Okay, so the next question is about bromine. Is one of the two liquid elements at room temperature and has a density. They give you the density now, 3.12 grams per liter. If you need 50 grams, if you need to get 50 grams, then how many milliliters would you obtain? So if you have bromine liquid, okay, and the density is given 3.13, you need to take 50 grams out of it. You can't. You can wait, but what is easier? You can take the volume. So you had to, so what they're asking, what volume would contain 50 grams? So they're asking this one, right? Volume, mass is given, and density is given. So the mass is 50 grams is what we are going to take out. 3.13 is there. Then you will get the volume, and you will get an answer of 16 milliliters. So if you remembered, and if you can derive the other equation, you know what is given, and you can find the unknown. Okay, I have another question here. I don't know how many such questions you get, but I haven't, this in the list I'm following. In this list, I have a question here. They're telling that they give you the density of water is 1 gram, which you should remember. 1 gram per liter is the density of water. So they're given a set of things as which one would float. They have given aluminum. I'm using symbols. By now, we should know these symbols. 2.7 need to be the same units. Okay, so remember they are the same units. Chloroform. I'm not going to cite the chloroform formula because you will not know. The density is 1.48. Again, same units. Check whether they are the same units too. Magnesium is 1.74. I mean, looking at it, you know, none of them would float, they will sink. Okay. But then fat is 0.94 grams per minute. So if you put a drop of fat into water, this will float. So this will be the answer. Fat would be the answer. All right, following with density. An application requires 775 grams. You need 75 grams of ethyl alcohol. Okay, I won't write the formula again. Just write ethyl alcohol. Okay. Now you have a graduated cylinder, and the density value of ethyl alcohol is, they have given the density to 0.785 grams per milliliter. So they are asking if you, how many milliliters of ethyl alcohol do you measure to obtain the desired mass? Okay, similar class what we did just now. We did in this video. So they're given the density, they have given the grams, they are looking for the volume. Okay, so density was mass by volume. So here would be mass divided by density. So I get 775 by 0.785, and I get the answer 987 milliliters. Yeah, 987 milliliters. Okay, that's how you get it. That's the form. Okay. Now dog barking, I'm very sorry, but a nugget of gold with a mass of 521 grams. So gold is the element. It's not a compound, it's an element, gold, 521 grams. We add it to 50 milliliters of water, and then it goes up to 77 milliliters. All right. So there's a 27 milliliters is the volume of the gold. So you can find the density. That's what they're asking. Yeah, density they're asking. So 521 mass divided by volume, right? 521 divided by 27. I get roughly 19.29. So we'll say 19.3 grams per. Okay. Okay, so this is a different kind of a question. This one, you have a sphere. Sphere. Okay. So the mass is, it's aluminum sphere. So mass is 85 grams, and diameter of that is, so the sphere, all the way going like that, is 3.92 centimeters. Okay. They're asking the density. They're asking what is the density. So they have given us the form. The volume of a sphere given by 4 by 3 pi r cube. So r is the radius. So 4 by pi r cube. R is the half of this, right? So I put 3.92 divided by 2 cube. Right? That's the volume. I got the volume now. Okay, you can calculate 4 times. 4 divided by 3 times 3.14 pi times 3.92. This, get the cube of this. Then you divide that, you divide 85 by this value here, and then here 2.7 grams per. Everybody? Here 3.85 is given, 85 top there. So 4 by 3 times 4 divided by 3 times 3.14 times get this answer separately. The reason you divide by 2 is because it's the radius here. This is the diameter. Okay, that's the whole length. Radius is half of that. So that's why I get the cube. That's okay. All right, we are moving. It seems that we are moving to different types of questions. This is about how many electrons are there. When they give the symbol, from the symbol with certain values, we should be able to have the electrons there. So here we have 52, chromium is popular, it seems 24. So sometimes it's like that, sometimes they would draw like that. It depends on the printing. Okay. So when you get to there, how many electrons are there? Because chromium is an atom. This number, the smallest number, has to be the number of protons, which is equal to electrons because it's an atom. There is no charge here, no charge there. Okay, so electrons would be 24. It's the number of electrons. That's the question. But if they ask atomic mass 52, and if they ask neutrons, that would be the difference between 52 and 24. Right. Another question there again for arsenic. 33, and they're asking what is the number of neutrons now. Okay, what will be the difference? S75 is the mass. Okay, mass is the totally neutrons and protons together. Then atomic number is just the protons. So proton plus neutrons minus protons, you get the neutrons number, right? So that you will get 42. 42 would be the answer. The reason is that you divide, you deduct the value of proton plus neutron and take away the protons from that. The nucleus of an atom. Okay, so this is just asking. Okay, so the question they're asking here is the nucleus of an atom contains the nucleus of an atom contains what? Protons and neutrons. That's why it leads to atomic mass. So that's the question. They're asking what is in the nucleus. Protons and neutrons. There are other things, but at this level, we do protons and neutrons. Okay. Yeah. Rutherford experiment. Asking the Rutherford experiment. That it's a gold leaf experiment. You took a gold foil, and then he sent rays, alpha rays. Alpha rays. It's actually 2He4. Alpha rays, helium atoms, and then some. Most of them went through, and some of them reflected. Some did that 180 degrees reflection. So what did it do? It says, so here's a true or false answer. In this experiment with the alpha particles and gold foil, Rutherford discovered the atom is mostly empty space. That's true, because this is the masses, right? So discovery was the atom is mostly empty space. Atom is mostly empty space. You need to know the theory behind it, because the reason it deflected 180 came because sometimes these alpha rays hit the nucleus, then it takes 180. But if it hit from an angle, then it goes deflected in a way. But because it is mostly empty space, most of the rays just went through that gold foil. All right, the next is about isotopes. Should watch about the isotopes video. I have done. Boron has 2 natural isotopes, 10B, 11B. Which isotope is more abundant in nature? Now, in this, you need the periodic table. right? Because they haven't given any percentages or anything for us to know. So one of the borons is in abundance than the other one, because the average atomic mass, is given by getting the mass of this, mass of that, and divide. You get the percentage of the mass of that, percentage of that. When you add them together, you get the average. So the average atomic mass is closer to one of them, the one that is in abundance. So when I look at the periodic table, I see the value 10.81 as the mass. So what you do is you see the difference between 10 and 1081 is 0.81, but 11 and 0.81 is only 0.19, right? So the one that has the smallest difference is the one that is in abundance. So 11B is the most abundant. Okay. Now we got two more abundant. Out of 10 boron and 11 boron, 11 boron is the more abundant one out of the two. Why? Because that value is the closest to the average atomic mass. All right. The other question is about zinc. They have given 64 Zn, 66 Zn, 67 Zn. These are all atomic masses. That's why you write the top value, right? 64, 66, 68, and 70. This is 70. Okay. So they're asking, what does it mean? They're asking the definition of isotope. It means the isotope. So they're given three. One is the isotopes differ by the number of protons. No, that's wrong. Another one is the isotopes differ by the number of electrons. No, that's wrong. But the correct answer is isotopes differ by the number of neutrons, because the definition is the atoms that has the same atomic number but different masses are the isotopes. Okay. So that's okay. The other question is about which one has the highest in the electromagnetic radiation. Electromagnetic radiation, I'll call it EMR. And which one has the highest energy? So if you take the whole range, you get this gamma. So you do the gamma rays, X-rays, UV, visible, IR, micro, radio. That's the way it's going. This is high energy, and this is low energy. High energy, high frequency. Low energy, low frequency. Wavelength is shorter in this end, the other end longer. When the wavelength is longer, that is less energy. Frequency is less. Okay. So out of the list they have given, is it X-rays? They're asking, is it IR, infrared? They're asking, is it green light, or is it microwave? So green light comes in the visible region. Microwave is here. Then IR is somewhere here. So then, but X-ray is the one that will have the highest energy. So the answer would be X-rays because of these reasons. I know this is a bit of a long video because I have so questions here to do. Although I broke down first videos into two videos, the same questions, but I think it's better to keep one video for the same thing. So where were we now? with the highest energy. Okay. All right, 1 minute. So I'm trying to get the questions up again. Okay, the next one is about highest frequency, the high frequency. So the question is about the higher the frequency of electromagnetic radiation, energy what? It is higher the energy. So if the energy is high, frequency is high, wavelength is short. So shorter wavelength, high frequency, higher. It is right too. Okay. Because it is the if the energy is low, the frequency is low, the wavelength is high. So the other question is about if say n is 2 here, and this is n is 4. When an electron goes from here to the other, to the higher shell, what is happening? The energy is absorbed because it needs energy to go up to a higher level, right? Electron is at lower level to go to a higher level, so absorb. When it stays there for some time and then comes back, that is the you get emitted. That's the emission energy. Energy is emitted. So remember, absorption is from the lower level to higher, 2 to 4. N equals 2 to n equals 4. Lower number to higher number. It is coming back, that is energy is emitted. The one that is absorbed here is given out here. In the shape of D shell. Shape of D shell, okay? P orbitals like that, dumbbell shape. This is like that. So the name for that is clover leaf. Clover leaf. That's a D orbital. This is a P. S is just a sphere. So remember, S is a sphere. P is a dumbbell shape. Dumbbell shape. And then clover leaf is the D orbital, which is what I've drawn here. Okay. Now the question is about how many orbitals are there. The energy level, the principal energy level, n number is 2. The simple equation to find out is n2 is the number of orbitals. Okay, so if n is 2, 2 times 2, you get 4 orbitals. Now, if the question was how many electrons, there may be a question later, but how many electrons, then each orbital can have 2 electrons, remember. So 2, that will be 8 electrons, okay? So this is the n number for the electrons, 2n squared. That is for the electrons. Find how many electrons. So you don't have to actually write SPB and go through the process. N squared is the number of orbitals, 2n squared is the number of electrons. But remember, first you do the n squared, then multiply by 2, because each orbital could hold 2 electrons. So how many orbitals exist in p subshell? They're asking how many orbitals. P subshell. Okay, it's 3, because S, P, D, F, you go by all the odd numbers, 1, 3, 5, 7. Remember, so it's starting with 1. So orbitals for P to be 3. How many subshells exist within the n equals 3 energy level? So that's the principal. And there's the subshells. If n is 1, subshell is 1. If it is 2, that's 2. Because first one means S. Here, S and P. 3, 3S, P, D. 4, 4S, P, D, F. 5, what happens? 5S, P, D, F, then G. From after F, we follow the alphabet. So the question is, how many subshells exist within n equals 3? How many subshells are there? The answer is 3. It's n is 1, 2, 1. If n is 1, subshell is 1. N is 2, subshells 2. N is 3, subshells 3. How many? Okay, that one. What is the maximum number of electrons that can exist within the n equals 4? So they're asking, what is the maximum number of electrons that can exist in n equals 4? I'll tell you the formula, 2n squared. So 4. Okay, the other question, what is the maximum number of electrons that can exist within F subshell? F. So they're asking in F subshell, what is the maximum number of electrons? Electrons, okay. So we know F has 7 orbitals. Each orbital could have 2. So the answer would be no S 7 because we did that. S, P, D, F, G. That's 1, that's 3, that's 5, that's 7, that's 9, because all the odd numbers we follow. Okay? All right. know one type of a question, how to answer, you should be able to answer another similar question. And what is the maximum number of maximum number of electrons in an orbital? So it's 2, right? 2 electrons in each orbital. There are questions going to be asked about electronic configuration. You have to know the off-bar rule, the filling pattern. You have to remember about the Hund's rule. It is going to go into that. Then Pauli's exclusion principle. Okay. This is theory. If you don't know, just go and watch those videos. The electronic configuration of phosphorus. So you go to the periodic table and find which position is phosphorus in. Okay, it is in the 15th. So you have to fill those electrons, right, in this manner. So you do 1s2, 2s2, 2p6, 3s2, then 3p3, right? That fills 10 and 15. But if they ask you to give the details of the last one, or that's how they're given in the multiple choice question, you know that you should at least have 1 electron in each Hund's multiplicity, because you cannot write this like that. You should give at least 1 electron to each, because these are all on the same energy level. That's why. Okay. The second part, we do it like that because Pauli's exclusion principle, because no 2 electrons can have the same quantum values. Everybody, so I've written the answer. Okay, then you also need to know how to write the abbreviated configuration. Abbreviated means if you are given an element of which electron configuration is asked, you have to see the nearest inert element or the noble gas, and then you follow that. So they're asking what is the electronic configuration of iodine? So the position of iodine, I'm looking at the periodic table, that's how I get it. So it's 53. The noble gas, 1 period above that iodine is krypton. So I put krypton in configuration, and you write the rest. So if you write the rest, you will get 5s2, 4d10, and 5p5. Okay, that's it. So these are the electrons. You can chromium. You find chromium. Chromium comes to 36. So 53 minus 36. These are the ones that is coming here. You get 17. So the rest you write for 70. Okay, you follow the same off-bar rule, but you don't have to write up to 36. You just put chromium in these square brackets. That is the abbreviated electron configuration. Then, okay, which element has 1 electron in the 6p subshell? So it's a question they're asking, which one will have just 1 electron? What it means is 6p1. Okay, so they are given a range. Okay, so sorry. So then they're asking what's that? So it is what the way to do it is you look at the P group, because you have a S group here, it's a P group and the P group. Okay, P group, the first one start with P1. So out of the ones they have given, go and see which one has. So thallium. I think this thallium is given, and it comes under 13 group. 1, 2, 3, 4, 5, 5th period. You don't have to go into detail. You look at the P block. P block start with P1, P2, P3, P3, P4, P5, then P6. Okay, so P1, that if you go down, you will see Italian is there. That's the answer. Because it takes all the time for you to keep on writing the configuration for all. Exam assesses you, an exam assesses you on your ability to answer a given question within the given time. It is not about your knowledge. They want to know, then that's when your PhD level or master's level, when you do a thesis, then their knowledge is checked. Here within the given time, so you have to be clever. That's the best way to find it out of whether you know the subject, but this is what's given and we are stuck with it. How many electrons, the next question, how many electrons are in the 4d orbital of ruthenium? They're asking how many electrons in the 4d orbital of ruthenium. Okay, how many electrons? So the answer I get is 6, because what you do is you go and look at the periodic table, then this time you go for the d orbital series. Okay, and see ruthenium comes to 1, 2, 3, 4, 5, 6. So if you see so d orbital, there are 2 things, right? Now the first one, the second level, you have ruthenium here. It's 1, 2, 3, 4, 5, 6. So that is d6. That's the filling pattern. Okay, but don't get mixed up with when it comes to d5 or d4, because d4 would show 5 electrons because of the stability factor. That's theory. You should have learned that in your electron configuration. So d6, it is ruthenium. That's the reason. It's in the 6th column. But when it comes to d5, yeah, d5 you can say 5 electrons. But when it comes to d4, if you have a case of d4, s2 and d4, it will be sd5. Remember. So this will have 5 electrons also. Although you can follow 1, 2, 3, 4, 5, 6 like in the d orbital. 1, 2, 3, 4, D5, D6, D7, D8, D9, D10, it goes, right? So 6, we can follow. 7, okay. 8, okay. 1, 2, 3, okay. But 4 will have 5 electrons, and this will have 5 electrons. 9 will have 10 electrons, and D10 will have 10 electrons. Remember that. Reason is because d orbital is more stable when it is partially filled. So S, if it had 2 before, S would have given 1 there. Please check on that. Okay. The answer is 6 electrons, ruthenium. Again, the question is how many electrons are there? This 1, 2, 8, deuterium, and 52. How many neutrons are there? How many neutrons? So how do you get the neutrons? 1, 2, 8 minus 52, you get the neutrons. So that comes to 76 neutrons. Okay, when it starts from the list I have here, the repetition of questions, then I'm going to end this video, but right now, so there are new materials coming, new questions coming. So in this one, 48 top and 22 here, and it has +4. And the question is, how many electrons are there? Okay, so normal times electrons would be 22. But when you have +4, that means you have lost electrons. That is why it has a positive. By how many? By 4. So whenever you have positive, you minus that one. All right, so this is the last one I'm doing. So they have asking atomic number for the element lead, Pb, plumber. So it's lead if you go and see the position of lead is 82, so that is the atomic number. Okay, so the other questions are going to be repeating. So if you know electronic configuration, you should know be able to draw well. So in addition to the ones I have mentioned, so it's more likely you will get electronic configuration. Possible things they would ask are for you to learn to get ready. To be, you should learn maybe sulfur. They will ask the electronic configuration. These are the ones normally they ask. That's why. Okay. Chlorine they might ask. Bromine. Okay. Chlorine or bromine. They won't go as far as iodine or something like that. There'll be sometimes d orbitals they might ask, maybe zinc, copper, chromium, because chromium is 4, right? So chromium, look at how them, or yeah, copper, zinc. So these are these ones should be okay. If they ask a question, which element has 3D configuration, 3D electrons configuration, you know it's d orbital, you go to d orbital, right? D orbital start with 3, then 4. So the top layer is 3, top d orbital period is three, the second one is 4. So not the first one, not the second one, the third one. So 3D, 3 is vanadium. That's the answer. Which one has? So always look at the d orbital. It has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I told you the one to be careful. 4th and 5th would have the same number, and 9th and 10th would have the same number of electrons, right? In the d orbital. So first layer is the 3, second is 4. Everything else 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if they give 3d3, it has to be top layer and the third. That's how we get orbit. All right, I told you to find the electronic configuration of sulfur. Please check it. Bromine. Okay, so those are the ones I have explained. You should be able to write it. It's going to be the abbreviated form. Then it's 2, 3d10, sulfur. Sulfur comes for 16th position. So sulfur, I can write not the abbreviated one. I can 2s2, 2p6, 3s2, 3p4. Okay, but if I'm asked to write the abbreviated form, then I put neon here and then write the rest, because that's the inert element or the noble gas that is there before it starts for sulfur. Okay. Last one. We're asking which element has 3 electrons in the 4p subshell. 3 electrons. We're asking which element has 3 electrons 4p subshell. So they have chromium, silicon, arsenic, and sulfur. Now, I told you if you go to the p orbital, first one is p1, p2, the elements p3, p4, p5, p6, right? That's the end. P6 is always noble gases. So when you say 4p, that means it's the period, right? So go by counting the first period, second period, third period, fourth period, and go for the 4 and go for the p for the one that has 4p. 4p, 3 electrons. So it has to be 4p3. So it has to be the third one and the 4th period. So whatever element here, that is arsenic. That's how we form it. All right, everybody. I stop there, and this is there'll be another video. Thank you.